right, well, we are going to start our third quarter this next semester with hopefully at the beginning, this chapter is a little bit easier at the beginning than where we kind of left off. Chapter three was kind of tough with solving quadratics in those five different ways. So I think to start this off, today's lesson will go pretty smoothly, and it should go pretty fast for you. So this first lesson is really just to review polynomials, which just means many terms. So you can go ahead and read through what a monomial and a polynomial are. And really that main difference is in the number of terms. So a monomial, for instance, can be the number 3. It could be 3x. It could be 3xy squared, but notice how there are no plus or minus signs. So to make a polynomial, you have to have a sum or difference of terms. So this, for instance, has 1, 2, 3, 4 terms. And so a polynomial, you're always going to have a plus or a minus sign in there. So a polynomial function, and you can see this big long equation, and that's just generic for, n could be x to the fourth, and then plus the a value is just your coefficient, just as up here I have 3, 3, 1 is the coefficient, and then the -4 is called your constant. So that's just kind of like a generic formula. Not every expression in math is a polynomial. So I just need to make sure that I'm going to kind of write in this box, this little green, but the must-have. So in order to be a polynomial, because I think in your assignment you have to explain why it is or why it is not, but the exponents on your variables have to be a whole number. So for instance, if we have the monomial 3x to the second, that's fine. But if you have 3x to the negative second, -2 is not a whole number. So this expression is not a monomial, aka a part of a polynomial. So that's what it talks about when it says a whole number, okay? If you have 5x to the 0, remember x to the 0 is just 1. So 5x to the 0 is a polynomial, 0 is a whole number. It says you cannot have negative exponents, which means the variables would be, under a radical. So you can have, for instance, your coefficient, which in this example 4x, 4 is called your coefficient, x is your variable. The coefficient can be any number. So you could have square root 5x, that's fine. But what you can't have is 5 radical x. That's not a polynomial, okay? And then the other thing you can't have is you can't have variables as your exponents. So for instance, 9 to the x power, that is not a polynomial, which I know I'm just giving you a single term right now because we're just looking at terms, but your variable has to be a base, like x to the 9th, that's fine. Okay, so this would be called, x would be called your base. Your exponent has to be, just to review, a whole number. The exponent, that means it cannot be negative. And the variable has to be your base, not your exponent. Okay, so that's just a lot of terms, maybe from Algebra 1 that you can remember. So the standard form of a polynomial basically just means you need to write that polynomial in order from highest exponent to lowest. And that doesn't mean you're going to have a term that has every exponent on it. But if we look at this example here, right now we have 1, 2, 3, we have 4 terms. And to put that in standard form, I'm going to look at my highest exponent, which is this x to the 5th term. So in standard form, we would have negative 6x to the 5th. and then plus our term that has x squared, because that's the highest, then plus 5x to the first, which you don't see, but it's really there, and then the constant always goes at the end. So you always want to order it from high to low, okay? I've already used a lot of this terminology up above, but you can read what the leading coefficient in that constant is. But it says, for example, in this polynomial right here, it also has 4 terms. This right here is called your leading coefficient. So because x to the 4th is the highest exponent, that puts that term in the lead, and then 3 is called your leading coefficient. And then in the same example, negative 8, my bad, negative 8 is called your constant. So that is still part of the polynomial. It's a term, but it just doesn't have that variable, okay? All right, so if we go on to the next page, the last thing really that we're going to review from Algebra 1 is the degree. And so the degree of a monomial, remember a monomial means one term only, so is the sum of the exponents all involved in that one term. So if you take a look at part A, example A, we have negative 6x squared y to the third z to the first. So don't forget, so if you add up, if it tells you what to do, it says the sum of the exponents of the variables, 2 plus 3 plus 1. So this would have degree 6, 3, 4, 5, 6, okay? So I added these exponents. For part B, the degree would be, we have 5x to the first, y to the fourth, z to the fourth. So if you add 1, 4, and 4, degree 9, okay? Now, the degree of a polynomial is a little bit different because you have more than one term. And so you don't just add up all the exponents that you see. You want the degree of the highest exponent on the variable. So for instance, let me kind of explain. In part A, this is called a trinomial because we have 1, 2, 3 terms, okay? Now, the degree of this first term would be 5 because we have just x to the 5th. The degree of this middle term, x to the first, y to the first, would be 2. And then the degree of minus y squared would be 2 because that's the only exponent we have. So what happens is you do not want to add those. This is not a monomial. You want the highest. So since the highest number we have here is 5, this has degree 5. And then for part B, you can probably guess, hopefully by now, that this has 1, 2, 3, 4 terms. And the degree of this polynomial of 4 terms is 4 because the highest number on the exponent or sum of exponents that you see is a 4. So this term has degree 4, this term has degree 3, this degree has 2. This constant right here we say has degree 0 because you, I guess, technically could write plus 6x to the 0 to equal it to just be 6. Because remember, x to the 0 is 1. 1 times 6 keeps it at 6. Okay? So I hope that makes a little bit of sense. What you can do now on your own is just examine this chart right here. This chart is basically kind of telling you an example of each type of maybe polynomial. And here's the difference. It's giving you the degree. So if we just review, remember 5 is a constant. That's the name of the degree. So if a polynomial has degree 1, that's linear. So if we look here, this is x to the first plus 4. So this has degree 1, and that's called linear. From last chapter, you probably should know this, but a degree 2, 4x to the second, is called a quadratic polynomial because the highest degree we see is 2. Here, this example right here, it has degree 3 because the highest, when you put it in order, is a 3 on the exponent. That's called cubic. and then so on, we have quartic and quintic. And then if we kind of divide this chart, kind of like this side is talking about degree, this side is talking about number of terms. So if it has one term, we're not talking about the degree now, we're talking about how many terms you have. It's called a monomial, which we started off with today. This next example has two terms. That's called a binomial. Here, this example has one term again, so it's a monomial. This next one has 1, 2, 3 terms. That's a trinomial. Really, once past that, like this last example, if it has more than 3 terms, we just generically call it a polynomial of 4 terms. If it had 5 terms, we would call it a polynomial of 5 terms. Okay? All right. So the last thing before you kind of start to work on the chart is you are going to kind of fill in this with me. So if you have this equation, this function right here, if we kind of review just really quickly the rest of our vocab. So in this expression, we have, or equation, I'm sorry, this is equation. P of x equals 2x to the third minus 5x squared minus 2x plus 5. So this 2 that it's pointing to, remember, is called the leading coefficient. If you don't know what this is pointing to the whole x to the third term, and that would be called our cubic term because it has degree 3. This is pointing to x, that minus 5x squared, and that is our quadratic term. This is not agreeing with me this morning. And this is degree 2. This is our linear term, and that's minus 2x to the first, so that's degree 1. This 5, our plain old number, remember, is called a constant. And then we have, what it's pointing to is this x to the third. This is really pointing to the degree of the entire polynomial. And remember, this is when it's written in standard form. It's always going to be that highest in front, if it's in front, if you will, if it's written in standard form, which means highest exponent of the terms to the lowest. Okay? All right, so that's really just the notes part. What I would like you to do is I'm going to do this first example with you, and then I would honestly like you to just pause the video. Actually, I'm probably going to go to a new part. I'll call it part 2 of the video. So let me do this first one with you. So what you're going to do in example 4 is you are going to write each polynomial in standard form first. Then you're going to state the degree, the type, and the leading coefficient. So let me do this one with you just so you kind of know what I'm talking about. So the only difference is, and this actually maybe, I probably could have made this a little bit easier, but it's going to help you for the notes that you do for later this week, but this actually makes it easier. So if you notice, we're going to have to do some combining like terms, like you did probably in 6th, 7th, and 8th grade. So we have an x to the third and another x to the third. So that is 2x to the third. We have a 3x and a minus 2x. Well, if you add those together, they cancel each other out. So you don't have to write 0x. I mean, you can if you want, but we wouldn't put that in the final answer. So honestly, in standard form, this simplifies in order to 2x to the third. Now, the degree, well, we have a 3 as our exponent, so this is degree 3. That means this is called a cubic expression. The polynomial, well, it's not really a polynomial, it's a monomial because we just had one term. So this is called a monomial. I can spell it right. And then our leading coefficient is just 2. Okay? So now I just want you to finish the examples. You may have to combine like terms and distribute first. and then check back with part 2 of the video to check your answers. Okay?